Hello guys, ClassofFour here, and today we are going to look at an algebra topic, and in particular it's going to be about sequences of series. So we'll go through three problems, and hopefully you get a better understanding of how to approach and solve problems in sequences and series. And this video is assuming that you already have knowledge on sequences and series, and that you just need, some practice and help as to how to solve these. So let's go and do it. So in an arithmetic sequence, which is a sequence where the difference between the consecutive numbers is simply adding a certain number, which is d in this case. We're given the information of this sequence where the first term is 2, and we have an unknown term u of 2, and we're also given u of 3, which is 8. Alright, so this is good. So let's go and solve a. A is telling us rather to find what the variable d is. So we're going to use a formula that uses the variable d. And this formula, if you studied arithmetic sequences before, you should know this. U of n is equal to u of 1 plus n minus 1 times the d. Alright, so how do you solve this to find d? Well, in order to do this, this is what you're trying to find. So the way to solve this is to isolate this variable so that all the other terms, however it may look ugly to you, but you have to move all the terms on the other side using algebra, so you end up with an expression of d equals something. And then after we find that expression of what d is equal to, we substitute all the unknown variables so that d is equal to just a slew of numbers, plus and minusing and dividing. And then hopefully we can simplify that expression to come up with one number in order to find what d is equal to. So let's isolate d. So u of n minus u of 1 is equal to n minus 1 times d. And then we'll divide n minus 1 on both sides to get u of n minus u of 1, u of n minus u of 1 over n minus 1 is equal to d. Alright, now that we have this expression that I was mentioning before, we simply need to substitute the variables that we don't know. And to do this, we have to identify what information we have. U of n is just symbolic for any number in that sequence. So this will be, and with the information that was given, we will use the third term. So in this case, it'll be u of 3. And u of 3 is equal to 8, so we'll substitute 8 for u of n. The first term, u of 1 rather, is given in the question also, and is 2. So we will substitute u of 1 with the number 2. Divide by n minus 1. Now n is the order in which the term is in. So let me clarify this for you. This is first order, second order, third order in regards to this. So we have the first term, which is 2, as the first number in that sequence. We have u of 2, which is the second term, as the second number in that sequence. And then we have 8, which is the third term, and this means that this is the third number in this sequence. So this means that n is equal to 3. So we will have 3 minus 1, and this is equal to d. Now, this is simple arithmetic, so we have 6 over 2, just d, and we then evaluate that d is equal to 3. So that means that 2 plus 3 is equal to 5. So now we know what our second term is, and 5 plus 3 is equal to 8, which confirms that our answer is correct. Now let's move on to B. So let's see what B is asking us. B is stating to find u of 20. So that means if you were to carry on with our sequence here, 4, 5, dot, 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 it's asking for what is u of 20? What's the 20th number in the sequence? So to find this, we will use the exact same formula. U of n equals u of 1 plus n minus 1 times t. Now, what we have to do is substitute all the variables so that you can find what number the 20th term in the sequence is. So let's do that. We know that u of n is really u of 20 because we're trying to find what the 20th term is equal to. We're then trying to find the first term. We're already given the first term by the information given by the problem. In this case, it's 2. We have n, which is going to equal to 20 because we're looking for the 20th term, minus 1 times d, and we calculated d in the previous problem. So we're going to bring this right here and put 3 right in there. So now that we have this, we simply just simplify this side to find what the 20th term is. And again, this is algebra, so I will go right at it. So 19 times 3. Alright. Plus 57, and this is going to equal 59. So our 20th term is 59. Now you could prove this by just simply adding 3 many times till you get the 20th number, but for time's sake we will assume, and I'm pretty sure I am correct. If I'm incorrect, by all means correct me in the comments. So we know that u of 20, which is the 20th term, is 59. So now let's go to the last question in this problem. So C is asking for find S of 20. Now S of 20 is the sum of all the numbers in the sequence until the 20th number in that sequence. So for this, we will use a different formula. The sum is going to be equal to n over 2 times u of 1 plus u of n. Alright, in this case we're finding u of 20, and we'll go about to how we solved it just like we solved all the other problems. We're gonna substitute the unknown variables and then simplify the expression so we get one single number to find out the answer. So in this case, n is equal to 20 over 2 times the first term, which is 2, plus u of 20. And in this case, we already calculated what u of 20 is. So we're going to bring that right in here, plus 59. There we go. And now we'll just simplify. 2 plus 59. And this is going to equal 610. So there we go. We have S of 20, the sum of all the numbers in the sequence until the 20th term is going to equal 610. So if you have any questions about what I've done here and how I approached these problems, go ahead and feel free to either just PM the ClassofFour or to just ask in the comments. So now let's move on to the third question. The second question, and we will talk more about sequences and series. Hey guys, so now we have the second problem to sequences and series. So this question deals with infinite geometric sequences. So I will give an example of just a geometric sequence. So we have 2, 4, 8, 16, 32, and so on. So in this geometric sequence, the r value, the rate at which the number is increasing by to generate the next term in that sequence is by a factor of 2. Okay? Now, this means that we're multiplying 2 by the rate, which is 2, to get 4, to get the second term. And to get the third term, we simply multiply 4 by r once again. So, this is a geometric sequence. Now, an infinite geometric sequence is basically, it's actually quite simple. It's just a geometric sequence that we say that goes on pretty much forever and forever and forever. So let's go to A. It says write down the value of r. So we know that our sequence that is given to us is this 32, 16, 8. So in order to find this, what we do is we put the term ahead of it. So we put the second term over the previous term. So let's take an example here. So we have our example geometric sequence here, and we don't even know what r is. We have no idea what it is. So in order to find it, we find a term and divide that term by the term before it. So in this case, let's choose these two numbers, 32 and 16. Now we'll take the term 32, divide it by the previous term, which is 16, and we get 2, and this is r. So in the exact same methodology, we'll use this way to find what r is, which is what the question is asking in this case. So let's use 16 over 32, and this is 1/2, or 0.5. Another way we can confirm this is to simply choose another example. So we'll choose 8 divided by 16, and this is also equal to 1/2. So this means that r is equal to 1/2. Perfect. Now let's find out what b is. So b, what is it asking us? Well, it's asking us what's the sixth term, which is also known as u of 6, in this sequence that we are given. So for this, we will use a formula to make it more efficient and to find it faster. So the formula to find a certain term in a geometric sequence is u of n equals the first term times r to the power of n minus 1. Now that we have this, we will go through the same way which you have all been taught, which is to simply substitute all the unknown variables on one side so that you can simplify that side and find out what the unknown variable, what the answer is. So in this case, we know the first term, u of 1, is equal to 32. R is going to equal 1/2, And we know this because we calculated it in the previous question. So we bring that right there. N in this case is going to equal 6 because we're finding the sixth term in the sequence. So now that we have all the information here, we are going to substitute. So u of 6, the sixth term, is going to equal 32 times 1 half to the power of 6 minus 1. Now, I am not a genius. I cannot compute this in my head. So I will use a calculator instead for this. So quite simply what I'm going to do is I'm going to get 0.5 and put that to the exponent of 5. So 0.5 to the power of 5, since it's to the power of 6 minus 1. And I'm going to multiply that number by 32. Now, this tells me that u of 6 is equal to 1. Now, let me go ahead and try to prove this to you. So, we have u of 1, which is 32, u of 2, which is 16, u of 3, which is 8. So what's u of 4 going to be? Well, u of 4 is going to be 8 times the r. In this case, it's 1 half. So u of 4 is going to be 4. U of 5 is going to be 2. And u of 6 is going to be 1. Now, some of you may say, hey, why didn't we use this method? I mean, I just got this without doing all this math. Well, what if the question asks you u of 30, or u of 20, or even u of 100? This would take much longer than using a formula and using algebra to compute or to figure out the answer. Alright, so let's move on to question C. And question C is saying, find the sum to infinity of this sequence. So, what does this mean? Well, let me illustrate for you. So we have a box, and this is going to be an example of an infinite geometric sequence. Now, the next term in this sequence is going to be half the area of the previous box. And likewise, we're going to just continue to get smaller and smaller, and so on. We will infinitely, if we were to just keep on going infinitely, we would eventually get to an area of a square that is so minimal that when you add it to the sum of all the areas of the boxes, that marginal increase will be so minimal that it really doesn't count. So, in the same sense, we are going to find a sum to infinity, and we can only find the sum to infinity as a definite number because r is less than 1. And if r is less than 1, this means that the area or the number in the sequence will get smaller as we increase in the terms. And this means that eventually we will be able to add all the numbers together, and it will not equal infinity because we're getting smaller and smaller. And we will just simply not count when we get to that really small number. So we can practically assume what the sum of the infinite series is. Now, if the rate is greater than 1, that means that the number is increasing as we increase the terms. That means that the sum to infinity of this geometric sequence, it's going to be infinity. And that's because we're just adding a bigger number to a bigger number to a bigger number, and it'll just get increasingly large forever. And we cannot compute that. Our calculators are not able to compute that. So, we will find the formula to do this. The formula to do this is the sum of an infinite series is equal to the first term over 1 minus r. Alright, so let's do this. We have the first term, which is 32, since we were given that in the question. And then after that we have r, which is going to equal 1/2. And we computed this in our, where is it? In our first question right here. So we will substitute and we will evaluate. So 32 over 1/2. Now I just skipped a step here, and basically I did 1 minus 1/2, which is the same as just 1/2. So I just simplified the process and put that right there. And we can see that the sum of this infinite series is 64. There you go. So now, if you have any questions regarding to this question, or any, if you have any confusion in the theory or such, feel free to drop a comment and I will be more than willing to create a video for that. Now we will move on to the third question. Hey guys, so now we move on to the last question in our sequences and series video. So this question is rather more rare, but it is something interesting to look at. So instead of being given a sequence, we have been given a function for computing terms in that sequence. So we will use this function to answer the questions A and B. So let's start. What is A asking us? It's asking us to write down the value of u of 1, u of 2, and u of 3. So this means it's basically asking us what's the first, second, and third term to the sequence. Now, we know that our function u of n is equal to 3 minus 2n. Now this is really simple. We will just, so for u of 1, let's find out. So we will substitute u of n for u of 1 because we're trying to find what u of 1 is equal to. We will continue with the equation 3 minus 2, and u of 1 will be used because we're finding the first term. And this is going to equal to 3 minus 2, because 2 times 1 is 2, and this is going to equal 1. So therefore u of 1 is equal to 1. Perfect. U of 2, very, very similar thing. We're going to substitute u of 2 equal to 3 minus 2. We carry the subscript of the n over here because we're substituting n, and we'll put 2 instead here. So this is going to be 3 minus 4, and this is going to equal negative 1. So therefore u of 2 is going to equal negative 1. Next, we find u of 3. And just like the other ones here, we will substitute u of 3 equals 3 minus 2. We carry the subscript of the term that we're finding for into n, and we simply evaluate the right side of the equation. 3 minus 6, and this leads us to negative 3. Good. So now we can list a sequence of the numbers that we have found out in as a sequence. So u of 1 is 1, u of 2 is negative 1, and u of 3 is negative 3. So this is our answer. Quite simple. And that's just how simple it is. So now let's move on to B, which is our next problem. So it's asking, find the sum of this of this function from 1 to 20 when you replace n with 1. So many people are confused with the exact notation of this. So I will go over it right now. So let me just copy down this question here. So we have this really scary looking sign, and this is going to be n equal to 1 goes to 20, and we're looking at the function 3 minus 2n. Alright, so this is a summation function, and it's asking us to evaluate this. So let me tell you guys exactly what each component is. This symbol right here simply indicates that you're finding the sum of something, and that something is this part right here. Now, to find a sum of something, you have to add multiple numbers together, and this is essentially asking us what's the sum of 3 minus 2, 1 plus 3 minus 2 times 2, and then we'll carry this all the way to 3 minus 2 to 20, and it's asking what's the sum of this function when I replace 1 in the variable n, and then 2, and then we keep on adding the value of it. So that is what it means. 1 is the counter as to where I start, 20 is the number as to where I stop, and the function here is simply the function I use to compute the number that I have to add in order to get the sum. So let us do this. Now this will take a lot of time if we were to just write everything out and do it mentally. So on a calculator, I will do this. Now if you have a graphing calculator, I can provide some instruction as to how to exactly do this. So on a graphing calculator, usually it's a TI, you'll have a math button on your left. So you want to press math, and then after that you want to go and press 0, the button 0. This will enter a summation formula into your graphing display calculator, and after that you want to put 20 on the top part of the summation sign, and then on the bottom you want to have x equals 1 on the bottom of your summation sign, and then in the brackets in front of your summation sign you want to input the function that you're given, and this is 3 minus 2x. Now don't get confused here. We are simply saying that x is equal to n because on the graphing calculator we cannot input the variable n. We will just input x. And when we get the sum of this on your graphing calculator, you should get an answer of negative 360. So that is the answer for this question. If you have any questions, if you have any confusions as to what I did here, feel free to just drop a comment. Now, thank you very much for watching, and I hope you have a good day.